Okay, well, I think we'll get started. Following up on the information that David and Mohammed presented, I'm going to speak a little bit more on actual real world deployment. So, my name is Kelly Maurer. I am the Director of Public Works for Cranberry Township, and we do have a short term traffic prediction model that we do use. So, I'm going to go into a little bit of how we use it and how it benefits us. So, just a little bit of background, just to let you know where Cranberry Township is. We are located in Western Pennsylvania, about 25 miles north of the city of Pittsburgh. We are a second class township. We are not a city. And just our area there, we're about 23 square miles, and I'm in charge of public works, and we have about 139 miles of roads that we maintain. So I think what makes Cranberry unique is we're at the crossroads of two interstate systems in Pennsylvania. So Interstate 79 runs north and south, pretty much from Lake Erie in northern PA all the way down to Florida. And then we also have an interchange here for I-76, which is our toll road, the Pennsylvania Turnpike. They both cross in this municipality, which is obviously a destination for people to be able to get on these interstate highways. And about in the middle 1990s, they also connected Interstate 79 into downtown Pittsburgh. And that was the construction of I-279. So that really was a housing boom in the area. We went from a rural community of 15,000 people, as you can see, in 1990 to about a little over 35,000 today. And they're expecting our population is going to top off at about 50,000 people. So a lot of that is growth, a lot of recreation, as you can see here in the pictures, and housing development. And that's kind of are a little bit about us. So talking traffic, which we're here to talk about today, I kind of zoomed in to show you the map is the location of those interstates. As I said, I-79 running north-south, Pennsylvania Turnpike generally northwest to southeast. And then we do have our highways, which would be state routes, arterials. Route 19 parallels the I-79 corridor for its length. So lots of exits. When there's incidents on the highway, the interstate, they do get off and kind of follow that Route 19 pattern, as well as when there's incidents on the turnpike. The picture I showed on the left is our main intersection, our hub to say, and that's the intersection of Route 19, Freedom Road, and Route 228. That intersection is dual lefts, dual throughs, and a right turn lane in all four directions. It carries about 80 to 100,000 vehicles a day, through the township. We can see from different data sources, it's about 50% of our township residents, and 50% of that is people from outside the township trying to get on these limited access highways. Wanted to give you a little overview of some of that, of our location with proximity to the interstate with the pictures on the bottom. The one on the left kind of shows Interstate 79 is on the right-hand side, and then Route 19 is on the left. A commercial corridor that we have. This doesn't even show the half of it, but definitely restaurants, businesses along that route, heavily traveled as it is. The middle picture is our connector between I-79 and the PA Turnpike. This was built within the last decade, 10 to 15 years. Before you had to exit one interstate to get on the other. Now you can have a direct connection, but people do get off for fuel and lodging and restaurants and things like that. And then the area on the bottom right, I wanted to show that's kind of our growing corridor. And this is an exit off of I-79 onto 228. The township actually constructed the fly under, if you can see kind of in the middle of the screen. And that is so you can get off 79 and directly go to that area on the north without having to touch any of our arterial network. That building there in the background is the Pittsburgh Penguins hockey team. That's where they practice. We're getting a Wegmans grocery store past that, and then there's a mixed-use development going beyond that. So really an area of growth for the township. So that was kind of just laying the scene of what traffic. We do manage traffic from a traffic operations center. That's myself with my back to everybody, but we do have a manager of this center as well as a crew of 3, and they are technicians in the field. So very important to keep these traffic signals, operating and moving traffic. We do that using Centrex Mobility by Econolite. That's our management system. We have used Centrax since the mid 90s when we were a closed loop system. And as you mentioned, we have kind of grown with them, becoming adaptive. Now it was EDaptive, which used signal performance measures, and now we're using Centrax Mobility. We do manage 54 traffic signals, 46 are in the township, and 11 signals are in 4 neighboring communities, and that's really so that you can get to those interstates. Talked about a little bit in the previous presentations. We have leveraged over the last 10 years about 10 million in PennDOT funding, and that's to keep our traffic signal upgraded. It is all connected by fiber. We do have non-invasive technology, loops and video. I'm not loops, radar and video, no loops. And then we are now changing out all our controllers, making sure they are the highest standard to be able to talk with all this communication. As far as this short-term predictive model, we are very fortunate to be located just north of Carnegie Mellon University. They have coordinated with us a number of times to test. We have a lot of traffic out here that we share our traffic data with CMU. It was the initial deployment of autonomous vehicles about 15 years ago were tested in Cranberry, and a lot of V2I, V2X technology is tested here as well. I also mentioned Southwest PA Commission is also our regional MPO, and we do a lot with them. But I really put this tagline on the bottom about research, development, and deployment. So one big part of this, and I kind of speak about in R&D, is the deployment end and making something that is really useful for the end user, easy to use, and really works for a benefit in the real world. So I'm going to kind of talk about that a little bit today. So I'm going to put up this screen. We had this presentation all prepared. We talk about incidents on the interstates, which is what we're going to talk about today. But I thought I'd share this one from this morning. So it's kind of a timely that we did have an incident on the interstate this morning. We had a cow that had fallen off a truck on Interstate 79. This happened about 7 a.m. this morning. The cow was finally corralled, I'll say, at 10:30 this morning. So, for over about 2.5 to 3 hours, we did have the interstate closed down. Obviously, our crews were out there assisting with that, but we also, these contingency plans and this predictive modeling were put in effect because all lanes of 79 were closed and all that traffic was rerouted to our Route 19. So kind of a apropos example today when I was making this presentation, but I'll kind of get into some details on how this all works, but that was a prime example. So this is where we started using this traffic predictive modeling. As I said, CMU is a great partner with us, and they have a smart mobility challenge they do every year. So in about 2015, they came to Cranberry Township and asked, what they could help us with. This was about the time we were testing autonomous vehicles and had a lot of interaction with them. And we really said the impact of when there was incidents on these limited access highways, how it really affected us, and we were pretty much at gridlock. And these happen routinely. So we came up with some contingency plans along with CMU and some of our traffic engineering partners. We came up with 10 different plans, and that's really necessary to flush traffic because it varies where the crash is on the interstates, whether it's north of our township south, people are getting off, if they're getting off at the interchange that's within the township, as well as on the turnpike. That is also a different route, a little more longer detours involved when there's incidents on that roadway. And then there's also differences in the AM and PM. So, we had these 10 flush plan routes that we were using. We were using them for about 3 or 4 years, and CMU came back and asked us what else they could help us with. So in about 2018 is the picture here, and they started talking to us about these the short-term predictive modeling. And if they could give us a heads up when the traffic was going to build in Cranberry, it wouldn't reach gridlock. We would be able to implement these plans ahead of time and keep traffic flowing. And I can tell you since this time, we've been using it since 2018. It is something we use weekly. It is still in effect. It is still helping us manage traffic. And, just it is we are a case study in success of this effort. I'm going to go into kind of how we are involved in this project and how it's user friendly for us. But if you'd want more information on this project, there is obviously a final research report that's available online. This has information on, the coding that was involved and the testing and all of that. But I'm going to talk more on a layman's terms about how it impacts us. So CMU met with us, and this does have different inputs that we talked about, how you have to put inputs into the system. We decided on an area of about 30 minutes from Cranberry Township. That takes you all the way into the city of Pittsburgh. When there's any crashes on the interstate, when it is closed, that is about what will impact us in Cranberry Township. So, that's between even the people getting off the turnpike, people heading into the city of Pittsburgh. So that has really been our focus. It continues to this day, but it even uses historical information of incidents and when they back up and how long it takes to hit Cranberry Township. They also input PennDOT traffic incident reports and also weather information. We do see a lot of crashes in the snow, in icy conditions, things like that. So the weather is important as well. So I talked about the study. Obviously, there's coding then involved on the CMU end. That's a rules-based plan that encodes this input and then gives us a proactive recommendation to put in a contingency plan. And that really is the crust of it. And what is so important to us is that we have that heads up in incident management to implement a plan, to try to flush that traffic out before it even starts. So the dashboard on the right there is what we see. It is up in our traffic operations center daily. It can give us that visual representation when we see the streets turning red or yellow, on the interstates, but as well as that forecasted model, that speed prediction at the bottom kind of tells us what is coming up and then maybe any incidents that have been reported. But I always talk about the deployment end in this, and what always amazes me is all of these algorithms and this coding and all this machine learning and how it's refined. For us as the end user is very simple. We do not manage the TOC 24 hours a day. It's only managed while we are here. But what this does is when there is an incident on the interstate, it does give us that heads up. We get the email that is shown on the right, and it's very simple. It tells us what plan is recommended, where the closure is, what time of day it is, and that is enough to have us that manage the traffic center, myself, our manager, and even the crew can see that. And that's what happened this morning. We got this message, we know something is going on, and we can start paying attention. At this point, our plans are still manual, and I'll talk about that in a minute, but you'll see that's our traffic management system there on the bottom right. Those would all change into our plans that we put in place. They are plans 80 through 90. They would take over when they're manually put in, but wanted to kind of show you, when I talk about how this has been used since 2018, I pulled up the data from the last month. So this is current. This is September and October in 2025, and we had over 20 alerts during that time. So this is not something that has gone by the wayside. We use this, as you can see, every week, and it really is a tool that helps us manage our traffic system. Talking about next steps, I guess, in this system is making this automatic. So we still put this plan in manually. We are in a pilot with CMU and with our traffic software developers to have this be automatic in the system. So we've been piloting this since about June, and has had some trials and tribulations. So I think we have a lot of contingency plans that's causing it a little bit of distraction or implementation issues, but really want this to be done so it happens automatically and it doesn't have to have a human interaction in this process. It's still the same, 30-mile radius. They're using KPIs here, and we can monitor side by side. The CMU alerts tell us when it begins, and then we get an email at the end when it ends. These alerts here that we're getting from this system are about every 10 minutes, and it would reassess. So we can see that we are confident in that the machine learning is doing its part and it's telling us the right time. We're just having a little bit of problems on the implementation end. So hopefully we are working that out. We meet once a week with the developers and providing them feedback, and that's that deployment piece. Lastly, I kind of wanted to share, they asked me to share some lessons learned. Obviously, we are using this system and the predictive modeling because it's prompt and effective traffic management. It helps us manage the traffic in our system. It was really a shift, as we're trying to do in most things, to be reactive and less proactive. That really, as I think Mohammed mentioned, that is um, decreasing that traffic from building. When we put in these plans, we also have a traffic alert system that goes out. We have 5,000 subscribers, and we tell them, crash in this location on 79, contingency plans in place, please seek alternate routes, and just makes everyone aware. Obviously, the end goal is to reduce congestion, increase safety, which we have found to be the case. Any of this machine learning and AI, as a municipal public works director with, budget constraints now, staffing constraints, anything we can do saves us money and time. We also use machine learning to do our pavement analysis on what roads we're going to pave. We use it in our winter maintenance. We have pavement sensors that give us a heads up in advance on when to deploy our crews. So really using this technology in many different ways. When I speak to other communities, I try to tell them to try new technologies. Some things may work and may not, but we'll never know unless you have a deployment partner to be able to test these. And that's the next step about being a deployment partner. I think some of the software that we're having going through now is we are being that deployment partner and making sure it really works in the real world. Obviously, the last thing I usually share is share your success, kind of what I'm doing today. We want to share this with other communities as well as academia and government to show that what you do really does make a difference to the actual motorists in real township communities. The blurb on the right is I do sometimes go on the local news talking about some of these efforts. And in this case, we had a broadcast last year that went national. So that's always, we feel like maybe we're doing something at Cranberry that we can share with others. I will answer any questions at the end, I think, on the chat group, but here is my information. We're happy to do tours or share our, positives and negatives and things that we have learned along the way. So here's my email address and phone number. Feel free to reach out to me at any time. And thank you for having me today.